Hi everyone, and welcome to the ioGAS 8.2 release webinar. Good morning if you're in Europe or Africa, good afternoon if you're here, and whatever it is if you listen to this asynchronously. We do know that a lot of people come back and listen to these webinars after the fact at their leisure, which is just great. So the run sheet for today is that Putra is going to very quickly go through the new features in a PowerPoint, but that's not going to take very long. It'll take 10 or 12 minutes or so. And then bravely, Putra will then illustrate all of the new features to you live in ioGAS. As always, during the webinar, while Putra is busy, please feel free to put any questions you have on the way through in either the chat box or the Q&A box. And one more thing before we get going, for those of you who are in Perth tomorrow, we have our GeoPub, and this time ioGAS Release 8.2 is the sponsor of that at the Mayfair in West Perth, kicking off at 5 o'clock. That's tomorrow on Thursday. And so you are most welcome to come along to that as well and have a chat about ioGAS. So let's bust right into it, and I will hand over to Putra, but I'll be keeping an eye on the Q&A box, as will Soph, I think, who's also online.
All right, hello everyone. So we'll just kick off with a bit of a presentation on what's new in version 8.2, and we'll kick off to the demo. So just a bit of housekeeping. If you can't hear me or see my screen at any time, I still have one of my monitors over there monitoring the chat, so just let me know if something goes wrong. Cool. All right, so what is ioGAS 8.2? So ioGAS 8.2 is quite a big release. We've added a couple of new features in here that people have requested over the years. And one of it being the new drill hole ribbon in ioGAS. And if you have used ioGAS for a number of years now, you know that we've always had a drill hole plot ever since probably about 10 years ago. But we have vastly improved it in this release, allowing you to do more if you have drill hole data. And we've also added a couple of other new enhancements in the analysis tools. So we've added our take on factor analysis through the Varimax rotation on principal component analysis results. We also now support GeoTIFF image underlay, which means that if you have some GeoTIFF image, you can import it to serve as an underlay in your attribute or variable map. And yeah, there's a lot of stuff in this release, and we'll go through it in the demo. But before that, I just run through just on a high level what sort of new features that we have in this release. So starting off with the GeoTIFF underlay. So this is something that people have requested in the past. We've always had links to programs like ArcGIS Pro or QGIS and Map Info. But if you really just want to take a look at where your data sits spatially relative to your geology map, you can just import a GeoTIFF layer to serve as an underlay in your attribute map or variable map. And I'll show you in the demo how this works. The new drill hole ribbon is obviously the biggest thing that we have in this release. So if you're in this call, probably I have spoken to you about it a few times. But if you haven't, what this is basically a new set of tools that allows you to look at drill hole data. So for once, we can now actually display text data, so categorical information, down as a strip log in a drill hole plot. We also have the ability to display multi-trace stacked strip logs. So if you have ever used data from our Osiris suite of solutions, so our cloud-based spectral mineralogy solution, if you have ever looked at output from that platform, you can now integrate that with geochem data in ioGAS. And there's a couple of things about compositing data from different intervals together, which I'll talk about in a minute. But you can basically combine your Osiris data and combine it with geochem and evaluate that using our new multi-trace stack strip logs. And there's a few other improvements in here, the way that we handle drilling data, which we'll go through in the demo. Right, so just as a side note, the way that we have improved the way that we can display drill hole data is we're not just limited to displaying it as a trace line anymore. So this trace line display, that's the default, and that is sort of the classic drill hole display that we've always had in GAS. But we've added a few more things since then. So we can now display things as a midpoint, area, downhole bar chart, and so on. So, and we now have the ability of displaying multiple holes or multiple variables in the same plot window. So it saves space within your ioGAS workspace, but it also means that you can get your interpretation a bit quicker. And this is an example of that multi-trace stack strip logs. So you can use not just geochem, but you can use it with anything that's compositional, right? So if you think of assay data, everything sums up to 100%. So it's logical to display it in a stack strip log like this. But you can also display things like RQD parameters, but also output from Osiris, so spectral contribution, for example. All right, so with the way that we display our drill hole strip logs, we now have enhanced abilities to display data down the hole, and we allow people to set this customization and allow them to save it within what we call a schema. And a schema, a drill hole schema, can be applied across the same set of holes or a different set of drill holes and between projects. So what that means, if you work for a large company that has a pretty set way of displaying things in certain colors or a certain way down a drill hole, you can basically save them and apply them the same way as you would with any other project files that you're working on. So allowing you to standardize your workflow, essentially. And I'll talk a bit about, there's a new concept that we have in GAS called numeric legend. And basically what that means is you can save a preset set of percentile ranges, basically with its own color coding, and saving that as a schema, which you can also apply in the attribute manager. So the attribute manager has actually been given a facelift as well as part of this work. So it's not just about the drill hole plot that we've improved, but we've also changed the way that we do things in the attribute manager. And a lot of it becomes a bit more logical now, and it fits in quite well to the way that we can apply, save, color, shape, and size schemas as a whole in ioGAS. And that's the same thing if you look at the way that we can now display categorical data down the hole. You're not just limited to the colors that we give you. You can customize them as you will, and you can also save them again in a schema that you can pass around to your colleagues, within your organization. Or if you're a consultant, you can save that schema file and send it off to your clients for them to use in their own projects. All right. So this just last one is just an example of the multi-stack strip log with Osiris data, just looking at spectral contribution down the hole. And you can display categorical columns next to this as well, which allows you to really look at, for example, log alteration, log geology versus your spectral contribution information quite easily. All right. And again, a picture or a video or a demo tells 1,000 words. So I'll save a lot of this part once we get into the demo in a bit. All right, but I would also like to allude that now we have a way of compositing data from different intervals into the existing workspace. So for example, if you start off with having a table of assay columns, and you want to bring in log geology, and if your log geology is in a different interval, so say if your assay is every meter or every 2 meters, and if your log geology is a bit irregular, so you have 0 to 50 meters as one lithology, and they exist in a different table, well, we can now composite data between different intervals into the same workspace. And there are 2 ways that we do this. The default is in using the maximum overlap join. And if you're merging a numeric data against another numeric interval table, we use weighted average as an option. We now support PostgreSQL import in ioGAS. So if you if your clients, if you're a consultant, if you guys are using PostgreSQL open source database, we now have the ability to bring in data from a PostgreSQL database as well. And that's located in the file ribbon within ioGAS. So one of the other big things that we added in this release is factor analysis, or our take on factor analysis. So now we have Varimax rotation of PCA. So Whereas, if you look in the literature, Varimax flotation can sometimes use different ways of factor extraction. But in this instance, we use PCA as the factor extraction method. And the output of this can be comparable to the use of PCA in that it maximizes the variance of the squared loadings of each factor, which means that the results that you see can be optimized to enhance some of the contrast in the loadings that you have in your factors. And we'll show you that in the demo in a bit as well. And some of the ways that people have asked for this in the past is, can we add new compositional transformation method? And yes, we have. So we've added 2 new compositional transformation method. One of it is ILR, so isometric log ratio, and additive log ratio. So if you have used other software to do this in the past, we can now do it in ioGAS. And really the best thing about this is that you can use it straight away as an input for something like PCA, or you can just use it straight off the bat to look at your data in compositional space. And that allows you to really get a better handle of how your data looks like in that compositional space. And here's another thing that'll be quite useful, especially if you have used some of our more advanced nonlinear dimension reduction technique like the UMAP. So we've added the UMAP in version 8 of ioGAS. And UMAP is it's an example of one of those techniques where it's not that easy to exactly explain what makes each cluster different in that low dimensional space. So the non-spatial variable plot allows you to plot the x and y axis of a map as the dimension reduction column. So in this instance, I'm using the 2 UMAP axis as the x and y axis in the map. And then the colors are based on the values in the particular element that's used to construct the UMAP. So that allows me to see which elements are basically most contributive to explaining how I see my clusters in the UMAP. You can use it with anything. So you can set your X and Y axis as UMAP. You can set X and Y axis as PCA, or you can even set it as geochem molar ratios. And then you can see how your molar ratio diagrams correspond to movements in your trace elements and things like that. So elements that you don't use to construct those dimensions. Right, so this is something that people have asked in the past, and perhaps some of you have filled out our survey last year. And some of the ways that some of the things that people have asked is the ability to basically improve the way that we can copy and export plots out of ioGAS. So we have taken a look at it, and we've streamlined things quite a fair bit. So now you have flexibility in allowing you to export plots within a window of multiple plots. So for example, like a scatter plot matrix, you also have an option of exporting a plot window into various file format. And essentially what that enables you to do is, if you have used the workflow recorder function before, which is something that we've added in version 8 of ioGAS, you can basically set up a workflow to record exporting images out of ioGAS to, for example, do batch export. So aside from standardizing the way that we do things, we also add the ability to fine-tune the size of your export. So if you ever got sick of exporting a plot out of ioGAS and they all come out as different size, well, we can now standardize the size of the export, which should make life a bit easier if you have to make standardized plots of a set size for you to use in presentations or reports or scientific publication. And based on popular demand, we have also now able to assign colors to mineral and rock nodes in ioGAS. So if you have used our mineral and rock nodes before, this is probably a lifesaver, right? Because the default display, which is light gray, it's, to be honest, it's not really that easy to look at when you're comparing it against your plots of thousands of data points. All right, there's a whole bunch of other improvements that we have in 8.2, but probably the biggest non-headline feature is the Windows native file browser. So this is something that actually came out from a visit to a client site a couple of years ago. And it's just a simple statement that, somebody was getting sick of looking at an old school Windows file browser in ioGAS. So we have now added a Windows native file browser, which means it's easier for you to look at the shortcuts and things like that in a normal Windows Explorer setting. Cool. And last thing, and before we jump to the demo, in MapGrid, now we are able to use custom bin range, which means that if you want to set your bin range other than the default that we currently have in MapGrid, which is a linear scaling, you can now set it to whatever you want. Basically the same options as you have in Attribute Manager. So just more flexibility there to how you display your interpolated MapGrid. And lastly, if you have ever used our line plot to do run charts in ioGAS, you can now plot mineral and rock nodes as lines in a line plot, which allows you to do a bit of a quasi QA/QC run chart kind of thing. So the x-axis can be your sample reading time, and the y-axis can be your assay value, and you can have different lines corresponding to your CRM values, and you can even add custom 5, 10, 20% composition to be displayed alongside those reference lines. Cool. All right, so let's just jump straight into the demo, just so we can get through a lot of this stuff. Just monitoring the chat. Nothing yet. All right, so let's get on to the demo, and I'll start off with the ioGAS demo data. So if you actually have ioGAS 8.2 in front of you, I'm going to run through a couple of files that are available within you, which you can find in the Open Demo Data menu. So at the moment, we have the standard demo data here. So this is from a place in Western Australia, pretty standard. And the new GeoTIFF underlay option can be accessed from the right-hand side toolbar of an attribute map. So there's a button there called Load GeoTIFF Image, which allows me to select any GeoTIFF file as long as it's geographically registered, which it should be because it's a GeoTIFF. You can now see that it's displayed that as an underlay. So you don't need to export it to a GIS program anymore to look at where your data sits spatially relative to where it is in the geological map sense. You have different opacity setting in display from 20% up to 100% opacity. The same thing applies to variable map. So let me just open a variable map right here. And I'm going to open the same raster underlay. And you can see here. So you can have a variable map with the same underlay, and you can have an attribute map with a different underlay. And I can open another attribute map, and I can open another different underlay. So you can have as many GeoTIFF raster image, import as many as you want, and they all get saved within the GAS file. So that should allow you to make different thematics, different interpretation, and especially with the variable maps, and allow you to quickly see where your data is spatially relative to that surface. Okay, so while we're on the subject of 2D map, let's open up the map grid. So now you have the option, if you have used this tool before, these first three options, that has always been in ioGAS, but there's a fourth option now that's called use other bin range, which triggers the drop-down menu below that. Otherwise, it's grayed out. So it triggers the drop-down menu below that, which allows you to set it to, for example, 50% cutoff. So you can set it to anything you want. So I got a bunch of custom bin range here that I set up for other things. So, if you have used our attribute manager before, you can create your own custom bin range. So this can be anything you want. I'm going to set it to 60% cutoff, set it to custom color ramp. And well, that looks particularly ugly, but let's change the color of this. There you go, much better. So basically, it allows you to do whatever you can do in Attribute Manager, but translate it to map grid. So this is something that people have asked before in the past, when they find that our map grid is incredibly useful. But if they want to basically repeat what they do in a variable map, this gives them that level of flexibility. All right, and while we're on the subject, you now have the option of exporting all of the plots in this window as an image file for each of these ones. So you do you do a batch export. And I'll show you that later on in this webinar video. But you can basically see here that it's created 4 different files. So output from just that batch export of MapGrid. Cool. All right, so let's move on to the drill hole demo data. And I'll show you the new drill hole menu. All right, so just straight off the bat, once you open the drill hole demo file, the first thing that you see is the way that we've changed, our drill hole plot, obviously. So this is a categorical column which we can now display as a real strip log. We can adjust the width of it, and we can adjust the size. We can adjust the colors, and numerical column can now be displayed as well. This is the classic trace line. We can also display it as a bar. We can display it as an area. We can display it as a midpoint, and we can also display it as a semi-transparent, as a transparent bar chart, which we don't have here. But we can also display it as area, but with a color ramp applied to it to highlight significant values and things like that. And as we can see here, you can have multiple holes in one plot window, and you can have multiple variables in one plot window as well. So this is an example of a group by drill hole plot. Over here in the middle, you have the multi-trace stacked strip log, which is also a new thing, which can display it next to a text column. And I'm just gonna open a new instance of ioGAS while we are here. And I'm gonna open the Osiris dataset because I had the webinar this morning and I foolishly forgot to show you this, but I'll show you this in this part of the webinar. But this is the Osiris demonstration file that we ship with ioGAS, just a generic Osiris output. And this is a text column, which we can now display next to Osiris spectral contribution data. And as a matter of fact, I have done a couple of presentations on this, last one at a conference in October last year, where I used a beta version of ioGAS displaying log alteration against spectral mineralogy, spectral contribution. And that allows me to see where the spectral contribution changes, how that's reflected with the geochem, but also with the change in the log alteration regime as well. All right, so with the Osiris data, actually, and this is one thing I didn't show this morning, is that we also now provide a new provided workflow for Osiris data. So if you've ever interested in how to make use of Osiris data using ioGAS, we provide a provided Osiris demo workflow, which just displays a combination of the plots that you see right now on the screen, but it gives you sort of a bit of a guidance as to what you can do with the sort of tools that we have in ioGAS. Okay, so that's an example of a stacked strip log, which you can also use with mineralogy, with anything really, with RQD, with geochem, as we did here. So if you imagine every assay data sums up to 100%, right? So if you sum up all of your major oxides, you can use that as a way of looking at elemental variation down the hole. All right, so what are we going to do now is we're going to actually open up a set of new drill holes, and we're going to take it one step at a time. So we're going to go to the select variables dialog. We select a couple of columns, and I'm just going to show you sort of the process. So you select the variables, of course, so we can select a text and a numeric column. And then we go to the drill hole ribbon, which you can see here. It's this entirely new thing. And we can now click on select drill holes. And the select drill holes dialog is kind of, if you've used our drill hole plot before in ioGAS, you know that it's changed quite a fair bit, but there's still some similarity in there. But the biggest change is in the fact that we have a selection history. So if you ever forgot what holes that you select, you now have a selection history to go back to. So it kind of works the same way as select variables. You know, you have your history in there. Sort list by values. This is a totally new thing. It's a new concept as well for us. So you can sort the list in this, or the list of available drill holes. You can sort it by values in any numeric column in the data. So the most commonly used application for this, you can sort it by values in easting, which allows you to sort the holes by the easting of the color, basically, and the color being the first item, the first file order, basically in that hole. So I'm going to use this to select basically the first 3 drill holes, which is because we're sorting by east, so we're sorting by those samples with the color that's all the way to the west. So you can use it as a quasi sort of section selection kind of method. But there's also another new tool that we have that allows you to select holes from the attribute map, which I'll show you in a minute. The bottom section is the same, right? So nothing much has changed in here. So it's just where you set your continuous variable and how do you configure your gap threshold and that sort of thing. All right, so we have now selected our drill holes, and we got 2 new buttons in here, default preference and strip log schema. I'll talk about strip log schema later, but we'll talk about default preference. So default preference is really where you set how the holes are displayed when you open it up for the first time. You can choose to display it as a field bar by default, the width of the line, and the width of the text column, the width of the of multi-trace plot, that sort of stuff. And it also allows you to set if you want to use a single window for group by drill hole or single window for group by variable. And remember to always look at the tooltip. If you hover your mouse over things in ioGAS, it actually is quite informative most of the time. So, you can hover your mouse over it and it will tell you exactly what it does. All right, so let's just leave that alone, but let's open a group by drill hole. And so group by drill hole is quite straightforward. So you group each collection of plots based on unique items in that hole ID or whatever column you use for drill hole ID, and it displays them as such. So by default, it displays it as a downhole bar chart for numeric column, which I can change to whatever I want. So I can change it to an empty bar chart. I can change it to trace line. I can change it to area beneath line, midpoint, and we're back to field bar. So here, these are the 5 options that you have. You can also color it up based on your attribute manager color. And if you have text columns like this, you can change the color, which I'll show you in a minute. But for the moment, we can also disable the text and the bounding line if you don't find that appealing to look at. So let's go to the column schema here. So here's a concept that's quite new that comes with the drill hole tool. We can now change the color of the text columns quite easily. So if, for example, I want to change oxide column that I use in here to the plot to the left to a different set of colors, like here, I'm going to change fresh to red and weather to green, for example. That gets translated straight away. And same thing if I change my Mayfic group as something like this. All right, so something distinctive. And I'm going to also change the way that we display each of these variables. So remember that when I click this button on the right-hand side toolbar, it applies the change to every variable in every plot within this window. But we now have the flexibility of only changing it for each column. So what that means, if I always want to display SiO2 as a line, I can do that. And I can also change it to a different color. I can change the width. And I can also change this to an open bar and change it to a different color as well. And I can also allow it to use a color ramp instead. So a color ramp basically highlights, it can be used to highlight high values within an interval. And it's quite a useful way of finding out where your high anomalies are sitting if you look at a color ramp. And it can be quite useful if you display it as an area as well as a field bar and things like that. All right, so I'm going to save this as a schema. And what's a schema? So a schema is a way for you to sort of make this permanent and applicable to other holes and also other projects. All right, so I'm going to I'm going to save it as an XML file, which is a schema in this sense. And I'm just going to close this, and I'm going to close this drill holes. And I'm going to open a new set of drill hole. And this time I'm going to sort by northing instead. But this time around, I'm going to go to strip log schema, which allows me this is the global strip log schema. So it's different than the individual plot schema. So there's two places where that lives. So you have a global schema, and then you have an individual schema. If you apply something to the global schema, which is what I'm doing now, that gets applied to every drill hole plot that I open within the session. And if you open it, if you only change it within a particular drill hole plot window, it's only applied to that plot window. All right, so I'm going to apply that schema. Sorry, wrong button. So if I click on the schema that I made earlier, it just says applied save config to 5 columns. Okay, so and then what I'm going to do is I'm going to open a new plot. And so this is a different set of holes, but it's using whatever I saved earlier in that schema. So that allows me to standardize the way that I display my drill hole between projects and between drill holes. But most importantly, because you can save it as an XML, you can send it to your colleagues or even your client if you're a consultant, and allow them to visualize data the same way that you do. Okay, so that's group by drill hole. Group by variable is a bit different, but it makes sense. So you basically group it by the different variable, but it's playing across holes. So this allows you to see variation between variables or columns across the same hole, across different holes. And then the other option is multi-trace overlaid, which is the classic display of drill hole plot that we've always had in GAS. So you just display the trace lines stacked on top of each other. And then you have the multi-trace stack. And this can be quite useful if you're looking at just major elements like this. And of course, you can use it with something from Osiris spectral contribution data as well. But you can also use it on geochem data, right? So I'm summing up all the major elements. And you have an option of looking at just the raw values, or sum everything up to 100% and recalculate each component to equate to a sum of 100%. Right. So in terms of sort of the drill hole stuff, that's sort of the bigger visual things that we have. And I'm just going to show you one workflow before we move on. And that is a new concept that we have called Safe Attribute Legend. So if I just open up a new classification diagram in ioGAS, I'm just going to create a new color group in here. So I'm going to reclassify a rock type in here, the mafic rocks, into a new group called andesite. I'm going to turn everything off except mafic and this new group called andesite. And I'm going to just reclassify these samples into my andesite group. And it's a pretty classic standard workflow if you use ioGAS before. You create a new column based on some EDA, and you save it as a new text column in ioGAS. So that's a concept that we've always had in GAS, but there's a new concept here called Safe Legend. So you're probably familiar with the way that we can save color attributes in ioGAS before through saving a .gap file. So this is quite an improvement to that process, because we can now save a legend, and we can choose to save whether we save the color, the shape, the size of the filter, and we can choose to even save just the color, right? So we can just choose to save just one attribute in this instance. So we're now going to save this as a legend, and I'm going to call it Geo Webinar. So I know which one to open. But one thing to highlight is that why I wanted to save it as a legend is because I want to retain the fact that I want to color my andesite as dark blue. Because if I auto attribute by the new column that I made, andesite is colored red, which I don't really want. So I want to apply that legend that I made earlier, apply it as an attribute to that column that I saved. So this load attribute legend function allows you to create an attribute group and then apply it to any column that you want in ioGAS. But you can also, of course, apply to the column of the same name that you use to generate those colors. So that is it's quite a change in the paradigm of how we apply attributes in ioGAS. But we've done this to streamline the way, so you can see that andesite is not colored blue as we want. But the reason that we've added this is because we can effectively use this to streamline how we display data down the hole. Because what this means, when you display this in a drill hole plot like this, you see that andesite is still colored as yellow and shale as this, darker yellow color. We can now go to the schema. We can load the legend that we save and apply the same colors as we saved earlier in the attribute manager. So you can see how the andesite is colored blue in here. So that's not a concept that we have. And along with that, we also have a concept of numeric legend, which I don't think we have time to really cover in this webinar. But essentially, it allows you to basically set, using your custom bin range, and allows you to save a preset range that corresponds to that percentile, and that each range corresponds to a unique color, shape, or size attribute, and that gets saved within a numeric legend kind of thing, which allows you to apply it to a downhole bar chart like this. So that is sort of that drill hole sort of workflow, which ties into the changes that we made in the attribute manager. One last thing before we move on from this space is the line plot that we have, and I'll show you another thing about how to select holes using the attribute map. So the line plot that we have in GAS, we've made quite a big improvement on this. So obviously we can now configure how each line plot trace line is displayed, much as we do with downhole plot, but we can also display text columns in this, which if any of you are dealing with regolith data, this allows you to display regolith information across a line chart of your survey line, for example, across a traverse. So that's one application. But also, if you are using portable XRF data or lab assay data, you can now create a pseudo run chart because you can effectively display a CRM composition as mineral and rock nodes in here, and you can adjust how they're displayed within ioGAS itself. I'm going to pick a color that's not red. I can change the line width. So you can assign your CRM as a line in this line plot, and it allows you to, of course, evaluate how your data performs over time, against a certified reference material. And you can create your own reference material composition in ioGAS. So we've always had this tool for a few releases now called export user nodes. So that allows you to export, your own CRM material as your own nodes and bring them into ioGAS through our rock and reference tools dialog. Okay, so that's line plot. So now let's move on to a different file. But before we do that, one thing that came up from testing this with some of our internal users is one of the questions was, can I select my holes from the attribute map 3D? So this is our classic 3D attribute map. And if you want to just display me the holes that corresponds to this selection, I can lasso the holes using the selection tool. And there's a button in here called select drill holes. And it will actually select those holes for me that corresponds to these points. So the holes that correspond to those points. And if I go to the drill hole dialog, that's what gets displayed in there. So it's quite neat, and it should allow you to select holes along a section, basically, and automatically select that instead of selecting them manually by hand. All right. So if we look at, let's just look at a different file to move on to the next section, which is the merging part of the workflow. So I'm just going to open, and this is a project that we're working on with our friends in DataRock. So IMDEX has a stake in a little company called DataRock, and we're working on this case study together It's basically looking at some geotech data along with the core RGB parameters, so colors of the core basically, and combining it with some geochem. So and this allows me to illustrate if we start off with a geotech data set like this. So this is output from their platforms. There's geotech parameters, so RQD parameters and RGB values of their core. How can we add geochem data to it, especially if they're in different interval? So of course they would exist as different, as if they're different intervals, then they wouldn't have a common joining ID, right? So they wouldn't have a common sample ID, which is why we've added this tool, this compositing tool, which is basically just an existing interval join, which allows you to join data of different intervals. So, and this assay data that I'm going to bring is from the MSDP project in South Australia. So it's based, if you're around and if you've been following Reflex and Index for a while, you've heard of the Lab and Rig project. This is one of the data sets from that project. So just from one of the holes, just data from portable XRF, but it's good enough for the purpose of what we're trying to do here. So you got, when you join data from a different interval table, you want to nominate the hole ID and the depth from and depth to. And by default, it uses a max overlap method for joining. But if you're merging numeric data against a table of existing numeric values, you have an option of using weighted average for numeric columns to calculate new interval values based on your interval length. So, all right, so we're just going, so the workflow is pretty straightforward. It just takes you to the column properties dialog and off you go. So you're just merging the data. And once it's successful, I just take you to a message. Compositing is successful. You've added this many columns. You have merged this many rows, and you have calculated this many weighted average. And if you look at your data table, you see that it's expanded quite a fair bit. So you get a bunch of XRF data tacked onto the end, along with lithology and that sort of stuff. All right, so what I'm going to do now is I'm actually going to show you a couple of workflows that's related to, well, after we merge your assay data together, what can we do with that? So we are going to use factor analysis now as an example of how we can, showcase a lot of the other tools that we have in 8.2. So I'm going to select, I have a set of variables that I know are useful for this data set. So I'm just going to run this through my PCA dialog. So factor analysis in ioGAS, our take on it is using Varimax rotation to rotate the principal component loadings and generate the Varimax rotated factors. So pretty standard in the way that we do things. So we have the PCA, we apply log10 transform, and everything else is still the same, except for the fact that in the scree plot dialog, so it is a bit hidden. So you can find the scree plot tab in the PCA report, and there's a little button in here called launch Varimax rotation. So the workflow is you run your PCA first, and then you use the scree plot and the Kaiser criterion, which is looking at eigenvalue higher than 1. So you're looking for the number of factors that are that have an eigenvalue of higher than 1, and that will be the number of that will be 4, and that's what gets picked in here. So we pick 4, and we just rotate basically those first 4 principal components, and it takes you to a different window. So 2 windows. One is the factor report, which tells you the sort of the eigenvalues of the rotated factors, and also gives you the scaled coordinates plot, which you can equate to the scaled coordinates plot in the original PCA report. So the way that the Varimax rotation kind of works is that you maximize the variation in the loadings such that your eigenvector arrows are more closely aligned with the factors themselves, and this enhances the contrast in the output. And as you can see from here, how the rotated result is the one in the bottom, and that's the original result. And what we're going to do now is we're going to use the output of this, and we're going to use it as the input for something like wavelet tessellation. All right, so I'm just going to run the Varimax rotated factor. And I've actually saved a workflow, a macro before our webinar to run a wavelet tessellation and to add up the first two axes of the Varimax rotated factors. So for context, the Varimax rotated factors that we're adding is the first two. So it's these two. And if I change the color of this based on the log geology, the Varimax rotated factor sort of enhances the contrast between the different rock types, but especially the difference between the dolerite and the basalt. So sort of that the difference between your intrusive and extrusive rocks, which are more closely highlighted in the Varimax rotated factors versus the unrotated factors, which you couldn't tell through this. So that rotation sort of enhances the contrast. And as a result, we're going to add the two factors using a macro here, and we're going to actually run them through the wavelet tessellation tool. All right, so the wavelet tessellation tool, the macro itself, generates wavelet tessellation on the sum of the two factors. And that allows me to basically, it's the best of both worlds. So looking at the contrast that you can see across both factors at the same time. And the result of this can be investigated, in conjunction with the strip log, but it also allows you to kind of try to understand why we see these variations in the first place. So if I display my rotated factor sum, and I display them as a drill hole plot, and what I'm going to do now is I'm going to actually select. So this is quite different. So there's a bit of an anomalous signature in here. And I can try to explain, all right, so these are quite different. So cluster-wise, it's quite different to everything else. And there's a new tool that we have called the non-variable plot, non-spatial variable plot, which allows you to explain the constituents of a dimension-reduced plot. So if I can use the Varimax rotated factor as the x-axis, and the y-axis as well. So this is the same distribution as your first two rotated factors, and which allows me to see, okay, these are the samples I've highlighted as anomalous, and let's see what they correspond to. And they correspond to this slot right here, which has relatively high iron, titanium, vanadium, and manganese compared to everything else. So, and then it comes down to the mineralogy and the alteration, and going back to the underlying geology to try to explain why they're different. So that's the sort of workflow that you can do with this. And of course, with the wavelet tessellation, you can create tessellated mean column that summarizes the boundaries in the data based on this geochemical sum domain that you get from the Varimax rotated factors. So while we're still on this subject, there's a couple of log ratios that we have added here in ioGAS for A2. One of the things that people have requested is, of course, the ILR, so isometric log ratio and additive log ratio. So you can use either one as input for something like PCA as a precursor transformation, or you can even use it straight off the bat just to look at the data in compositional space a bit better. So if we look at isometric log ratio, it will produce the same number of columns as the one that we select in the input space. So it just projects it into the ILR space. So it's going to be a bit messy because we have 23 columns. But if I just select one of it and we change the color of it back to our log geology, and we can compare this, with the raw data, and the data being in compositional space should enhance some of that relationship that we would expect to see, and sort of exposing sort of data that's been subject to effects of closure and things like that. So you got ILR transform, and the other one is we have additive log ratio, which just uses one of the elements, and it uses the first element in the list of selected variables as the denominator. So the choice of denominator is arbitrary, but we want to pick an element with non-zero values, and it can also be a component that ensures the composition of the row sums to unity. But generally, you can also choose something like an immobile element for this, and you can see that it produces n-1 number of output columns. So if you have 23 columns, it outputs that -1. Okay, so that is the new transformation option method that we have. And I'll just finish off. We got a few minutes, and then we'll open it up for a quick Q&A session, if we have any after this chat, to tackle any questions that any of you may have. And of course, feel free to use the chat window here if you have any burning questions or anything. But I'll dedicate sort of the last few minutes of this webinar just talking about the different export options that we've added in this release. So I've shown you that we can now sort of create plots out of ioGAS in various streamlined ways. And the biggest change that we've put in that space is really the way that we have streamlined the way that we have the copy option now in the right-click menu, and we also have the export plot option, which allows you to effectively set sort of an automated exporting option, especially if you use it in conjunction with the workflow recorder. So if you imagine if your application is, imagine you have 20 drill holes and you have a bunch of wavelet tessellation plot and strip log, and you want to do the same thing every time. So you can set up a workflow whereby you record the action of creating an export image for every XY plot that you have, just looking at your elements of interest, but also the drill holes of interest. And you want to do that every time you run through a workflow. And you can sort of help you automate through that process. And that's why we've added the ability of exporting within each plot type in ioGAS. So export, the difference between export, and I'm going to use this opportunity to highlight the fact that we have a new Windows viewer option in here, which can also be seen in the open and the export window. But also, if you have a variable plot like this, you have an option of doing a batch export of every plot within this window, which can also include the legend as well. So this is one thing that people, especially some of our clients who are consultants in the industry, they would like the option of exporting the legend of a plot in a batch export. And that kind of allows them to streamline some of that process a bit better, especially when they want to export the legends to be manipulated to change the colors and to make it pretty to use in an AXX announcement or something like that. So a lot of these options can be found at the top in almost every ribbon. So of course, a lot of this is related to the graph window, of course. So you can find the export option in the graph window at the top. And then you also have it in the map window as well. So there's a bit more flexibility. And if you ever like to export a plot as a PDF, you also have an option, a new option here to change the size of the export based on your page size and your orientation as well. And you can also adjust the dimension of an exported plot if you export it as a PNG file. So that option is also available in all of the export file options as well. And you can choose to scale the symbol size, which is what we use for the symbols all around what we use in the plot. You can choose it to log aspect ratio, and you can choose to use fixed symbol size as well. Okay, and sort of in the exported plots, I'm just going to show you one that I made from this morning. This example of a PDF file. So this is an example of a PDF export that we made from this morning. And it's just one thing, if you ever want to export it, put it in your shared drive in your workplace, you can quickly share your interpretation output with your colleagues, right? So, and you can, again, automate some of this process of exporting plots out of GAS. All right, so that sort of sums up sort of the new features of ioGAS 8.2. I don't think there's any questions in the chat, but we'll open up sort of the last 5 minutes of this quick Q&A, and then otherwise we'll just close it up. Over to you, Dave.
Yeah, now's your chance to ask any questions you have. But just to reiterate what we always say at the end of these seminars, if you have any requests or comments, please just contact us and send them in. We listen to all of them. Might take us a while to get around to some of the requests, like, for example, putting the GeoTIFF under the attribute map, but we do get to it eventually. And just some commentary from this morning, there was a little bit of a chatter about calculated mineralogy from multi-element data as well. So if you've got any opinions on that, either strongly positive or negative, we'd certainly be interesting in hearing that. We've had it on the to-do list for about 10 or 12 years, but held off for various reasons. But if you feel strongly about it, then please get in contact. I did in the chat put a picture of the QR code where you can register for the GeoPub tomorrow night. We just use it to give the venue warning of how many people might show up. But of course, you're all most welcome to come along to that. But if there's no questions there, Putra, I think we can wrap it up. As usual, the webinar this recording will be made available on the website as well, so you can watch it again later. You can see there's a lot in the release. You might want to watch it in slow motion actually to see what Putra is doing when he was showing off some of those new features. But it's certainly a great ready reckoner and a reminder. I get a lot out of watching Putra use gas actually every time.
Thanks, Dave. And again, if any questions, you know where to reach us. And yeah, keep in touch, and we can't wait to see what you come up with using 8.2.
See everyone. I'll see some of you tomorrow afternoon.
Thanks, everyone.